Good morning, everybody. Today is 1st of October 2020. My name is Ferhan Mazher. Right now, I am in the 10 Cambridge class, and the subject we are studying is Physics 5054. The today's topic on which we are working, the chapter we are studying is light, and the topic on which we will have discussion. That will be the characteristics of the image. Characteristics of the image in plane mirror. In the plane mirror. Okay. Whenever you get a chance to come in front of a mirror, you have remember one thing. Today we are going to discuss the characteristics of the plane mirror, the image formed in the plane mirror. You have mirrors, and some of those mirrors might be plane mirrors, and some of them might be curved mirrors. How you know this is curved or it's not? It's a plane. In the plane mirror, the image do not become magnified. The image do not become enlarged. Okay? For example, I saw a mirror. There was a mirror in your class yesterday. It has two mirrors. One was plane, one was curved. So, in the plane mirror, the size do not change. But when you look into the curved mirror, most of the vanity mirrors, they are curved. So when you see through them, the size is little larger. Okay, they are kind of zoomed in. Okay, on your face. Okay, so I am purely talking about plane mirror. When you come in front of a plane mirror, and for example, if I am standing here and here is the plane mirror, and I look at my image. So we are going to study the characteristic of that image. When I stand in front of the mirror, for example, if I will raise this hand, this is my right hand. The image in the mirror, he will be looking at me, and this hand will go up. And if you pay attention, that hand is not the right hand. It should be the left hand. So when I raise my right hand, the image in the plane mirror will raise its left hand. For example, if I raise my left hand, and I am standing in front of a plane mirror, when I will raise my left hand, the image in the mirror, this hand will go up. And if you try to understand, he is facing me, and this hand goes up, so it is his right hand. So the left of the object, when you are standing in front of the mirror, you are object. The left of the object becomes the right of the image. And the right of the object becomes the left of the image. This happens when the image is formed in a mirror. Okay, you can observe yourself. This is called laterally inverted. This is called laterally inverted. The image is laterally inverted. Laterally inverted means, we also call it left to right invariant. It means that the left of the object appears to be right of the image, and the right of the object appears to be the left of the image. You understand?
Yes, sir.
Okay, that is the first characteristic. When you stand in front of the plane mirror and look at yourself, my hand, when I stand in front of the mirror, my hand is upward and my feet are downward. If there is a plane mirror in front of me, and when I look at the mirror, what the image, its its head will be also upward and its feet will be downward. It means that the image, the up of the object and the up of the image is same. We call it that the image is erect. The image is erect, or we say the image is upright. The image is upright, or we use the word the image is erect. It means, what does it mean? It means if I have an arrowhead here, or suppose I am wearing a hat and it's on top of my head, it's here. In the image, the hat will be also upwards. Okay? This is called that the image is erect. Okay? That's the second characteristic of the image formed in the plane mirror. Then there is also another characteristic which we call, try to understand this idea. This idea is little, it can confuse you. The wording is very simple. Whatever is the height of the object, whatever is the height of the object, same will be the height of the image. The size of the object and the size of the image in the plane mirror is same. The size do not change. So there is one question. For example, if I put this big mirror here, suppose I put it here, and I stand here and I see myself, and suppose I am 5 feet and 10 inches. My image, my whole body image might be visible there to me. But the word I am saying is that my height and the height of the image will be same. This is what I am saying. But you can say that this mirror in which your whole body is visible, its height is not that much. But the height of image you do not measure like this. Understand? If I will stand in front of a mirror, I will put a scale beside me and I will ask Hadia to check what's my height. He will check. And then we will look into the image. If I have a plane mirror in front of me, and we will look into the mirror. But we will not put a scale with the mirror. No. You put a scale, still you put a scale with the object. And then you see through the mirror. And in the mirror you see, in the mirror you look at the scale, the image of the scale, and from there you check the height. You understand? Okay. So, simple word, the height of the image and the height of the object will be same. Okay? I mean the length of the image, or you can say the size of the image and the size of the object is same. Another interesting thing. The size of object equals to size of image. The next characteristic is that if you stand in front of a mirror, for example, here I have a mirror. If I stand 2 feet, the distance between me and the mirror is 2 feet, the image which will be appearing in the mirror, that will be also at 2 feet. If you move further backward, now suppose I am at 4 feet distance from the mirror, my image will be also 4 feet behind the mirror. If I am, let's say, 5 feet from the mirror, the image will be also 5 feet behind the mirror. The distance of the object from the mirror is equal to the distance of the image from the mirror. It means that the distance of object from the mirror is equal to the distance of image from the mirror. For this purpose, we can do an experiment also. A very simple experiment. Take our drawing board, and on that drawing board, put a graph paper. Take our drawing board, and on the drawing board, put a graph paper. So suppose here I have placed a graph paper. So graph paper will have grid. You know, the graph paper will have grid marked on it. You know that? Yeah. And here place a mirror. You see? You can understand this? What is this? So it's a graph paper, and here the blue color thing, that's a mirror. So it's like this. You see, it's like this. You have a graph paper, and this is a mirror, and I have placed the mirror like this. Okay? A graph paper like this, and a mirror like this. I put the mirror like this. So this is this diagram. This diagram is representing that thing, that situation. You understand? Now, place a pin here and name it as A. You can see that pin A is the object, and its distance, perpendicular distance from the mirror, is 1 centimeter. When you look at the image of this pin in the mirror, look at the image carefully. The image will also have a grid. Image will also show the pin A, and the distance of the pin A from the mirror, from the grid in the image, you can tell that will be also how much? 1 centimeter. Do one more thing. Take another pin. Put a pin here. Let me name it as B. This is now my object, pin B. And what is this perpendicular distance from the mirror? 2 centimeter. Then look at the image of this pin in the mirror. The image will have a grid, and the image will have the image of pin B, and check how much it is behind the mirror. It will be also 2 centimeters. Then put a pin here. Suppose, let me call it pin C. What is the distance of object pin C from the mirror? 3 centimeters. Then look at the image of this pin in the mirror. It will be also 3 centimeters. So it's the distance of the object from the mirror and distance of its image from the mirror, they are equal to each other. Okay? You understand this?
Yes, sir.
Another important thing in the image formed in a plane mirror, we call it front to back inversion. Front to back inversion means if stand in front of a mirror. For example, here I have a mirror. I'm standing in front of a mirror. I am object. Point towards the mirror. And your image will point towards you. If you point that way, the image will point this way. This is called front to back inversion. Okay? Answer? Answer. Last thing about the image. Whenever you stand in front of the plane mirror, let's say I am standing in front of the plane mirror at a distance of 2 feet. And when I look through the mirror, I get the perception that my image is behind the mirror 2 feet. But if you actually go there and see 2 feet behind the mirror, there will be nothing. For example, here, when you look at the image of A, you find that 1 centimeter behind the mirror there is image of A. When you look through the mirror. But if you actually go behind the mirror, there will be nothing, there will be no image. If you look at the sea, you look through the mirror, you look at the image of sea, you feel, you get perception, you get the, you just get the idea that the sea, image of sea is 3 centimeters behind the mirror. But if you actually go behind the mirror, there will be nothing. There will be no image of sea there. You are only able to see that image when you look through the mirror. If you change your angle, that image is not there. You are able to see the image only when you look through the mirror. Otherwise, no. For example, so the image is, just take an example, the image is virtual. Okay. The image which is formed by the mirror cannot be captured on a screen. The image is only visible to those who look through the mirror. If you go behind the mirror, there will be no image. The image is behind the mirror only when you see through the mirror. This kind of image is called virtual image. What we call it? Virtual image. Plane mirrors, they make virtual images. The opposite of the virtual is real image. You have mirror? Do you have mirror? Yeah. That day we showed with this mirror, I showed you the real image also. Okay? So, for example, when I look at these are 2 mirrors. Here we have 2 mirrors. This one is the plane mirror and this one is the curved mirror. How do I know? Because this mirror, in this mirror the size of my face do not change. But when I look at this, it is kind of zoomed in. Okay? It shows bigger. Okay, so the real image, you see, when I look at here, the image of myself which is inside the mirror, you can see, I can see my image which is inside the mirror. That's virtual image. But this mirror can also make a real image. I showed you that day. If we switch off the lights, and I can show maybe we will be able to show the image. यहाँ पे वो बहुत
फिर इसका मुंह दूर कर ले।
करते अभी पहले वही
कर दो।
लेके आओ इसको जरा।
जो। बस मुझे आ गया।
In the video, can we see that?
Yes.
Okay, so now this image which I made on the wall, you see this image which is now on the wall is of that outside scene. You can see the grill, you can see the greenery, I think, I hope you can see that. That's a real image. This image is not virtual. To see this image, you don't have to see through the mirror. This image is formed by this curved mirror. But you see, this image is captured on a screen. This image is visible to everybody. To see this image, you don't have to look through the mirror. It's a real image. But the image which, see, this image, yeah, this is of that outside scene, okay?
Sir,
Yeah.
the image is inverted.
The image I think is inverted. Yeah, the image is, this is sky. Okay? The real image is always inverted. Okay? So I hope you understand what's the meaning of the real image, what's the meaning of the virtual image. This frame is right?
Yes.
Achha. So it's very important the image is virtual. The image which is formed in the plane mirror is virtual. And the curved mirrors, they can also make real image. We just showed you the real image. The real image can be captured on the wall. And to see the real image, you don't have to look through the mirror. Okay, so that's a real image which can be captured on a screen. Okay, you understand? Okay, so these are the characteristics of the image which is formed on the plane mirror. One very important thing is, sometimes you might have noticed that when an ambulance comes and you look at the front of the ambulance, the word ambulance is written in front of the ambulance. But that word is written in a very weird manner.
Yes.
It's not properly ambulance, properly written from, what do you say, from the left to right. The word ambulance is not written like this. The word ambulance is written in that manner so that when a vehicle is going in front of the ambulance and the driver of that vehicle, when he looks in the back view mirror and that word will, in the mirror, it will go under lateral inversion. So what will happen? When he will look at the image of that ambulance in his back view mirror, the word ambulance will properly show up in the image. Do you understand this, what I'm saying?
Yes.
Okay, another thing. What was that? The word ambulance. Okay. We are done with this thing. We are done with this Singapore thing. Okay. Another important thing I just size of the object. So don't forget these. Okay. So let's move to the next thing. How much time I still have? I have like 10 minutes. Okay. So let's learn how to locate the image in a plane mirror. For example, I can show you some examples in which we will show how to locate the image in a plane mirror. For example, suppose Here you have a plane mirror. And suppose here you have an object. Let me call it A. This is my object. And suppose here is the observer. Here is the observer. This is observer who is looking into the mirror. Okay? So now how you draw or how you locate the image. There are two rays of light, maybe you might use three rays of light, but you see it's very simple. What we do, one ray of light starts from the object and falls perpendicularly onto the mirror. It is making how much angle? 90-degree angle with the mirror. And remember, if the light will strike the mirror at an angle of 90, it will go back on the same path. The path it came, on the same path it will go back. If the angle between the incident ray and the surface of the mirror, if that angle is 90-degree, the light will go back on the same track. So that is first ray. And then I will prolong it behind the mirror. I will prolong that ray behind the mirror, but when I prolong it behind the mirror, we prolong it with the dotted lines. Dotted line, I mean. Then you can, you see, this is the object, this is the observer. Check what is the middle point. What is the midpoint between whatever is the distance with the help of the scale, you can measure it and check what is the midpoint. So from that midpoint, draw a normal to the surface of the mirror. You understand what I'm saying? This is our own trick. Okay? What I have done, I have marked the middle point between the object and the observer, and from that point I have marked a normal on the mirror, and then with the help of the scale, join the object with this point. Join the object with this point with the help of the scale, and from here join it with the observer's eye. Automatically, this angle of incidence and this angle of reflection, they will be equal. Automatically this will happen if you follow this trick. Then this is your reflected ray which came into your eye. Prolong it behind the mirror with a dotted line. This reflected ray, prolong it behind the mirror. Where it intersects the other line, there you will see A prime, that is the image. You understand?
Yes.
Do you understand? Okay? So, let's do another thing, another example. Do you understand this thing?
Yes.
Okay. So, we can do one more example on locating the image in a plane mirror. And for that purpose, let's say this was a single point. This was a single point. And let me show you. Suppose this is a mirror. Suppose this is a mirror. And you have a object here. Let me A. And you have an object here. Let me say this is A, and this is B, and it's a line. So this is my object, AB line. Now I want to locate its image. And suppose we have an observer which is here. Here we have an observer. This is my observer. And I want, when he will look through the mirror, where he will see the image. That's the question. Okay. So now I am telling you a different technique. Okay. So try to understand. Join A with the mirror with such a line which makes 90-degree angle with the mirror. And that line, so the light comes and light goes back. Okay? And then prolong that line behind the mirror with a dotted line. Okay? Now, from this, okay? This is a different technique which I am trying to tell you this time. Huh? From here, start anywhere. Fall it here anywhere. Okay? Wherever you like. Chaliye. I want to start a ray and falls here. Okay? This is a different technique now. So it touched the mirror at here. At this point, draw the normal. This is the actual technique which is technically used. Draw the normal. Check how much is the angle of incidence. With the help of the protector, check how much is the angle of incidence. Check how much is the angle of incidence. Same angle of refraction. Mark angle of refraction with the help of the protector. The angle of incidence and angle of refraction should be equal to each other. And then draw this line. With the help of the protector, the angle of incidence, angle of refraction should be same. So then draw this line. Okay? Very simple. Ma'am, can also please use something?
No.
Okay. So, you see, and then prolong it behind the mirror. Wherever it intersects, that is A prime. That is the image of A. Try to understand this thing. Now I am going after point B.